Hi guys, welcome to another maths tutorial brought to you by Direct Tutoring. Today we're going to have a look at further questions in the 2019 non-calculator paper. This is video part 2 of the breakdown. We're going to have a look at questions 4 through to 6. Part 1 had covered questions 1, 2 and 3. So if we take a look at question 4. Question 4 is a arc and sectors question. It gives us sector of a circle with centre C, which has a angle of 240 degrees, and it says the radius is 30. Calculate the length of the major arc, so that is the larger side that you see here. This is the minor arc, and this is the major arc. So we want to find the length from A all the way around to B, and we have to take pi as 3.14 because this is a non-calculator paper. So first of all, we need the formula, and the formula for the arc length is going to be the angle over 360 times by pi times by d, the diameter, because we're trying to find the circumference of the circle essentially, but the circumference of only a specific part of the circle, in this case 240 degrees of the circle. So if we substitute the values that we know, so it's going to be 240 divided by 360 times by 3.14. Now the radius is 30, so the diameter will be 60. So if we tidy this up, we can take the zeros off top and the bottom of the fraction, so we're left with 24 over 36 times by 3.14 times 60. So before I deal with the 3.14, I can simplify this down to 2 over 3. I'm going to multiply that by 60. So I'm going to get 60 over 1. I'm going to put that in a fraction form, and then times by 3.14. So by multiplying fractions, you're going to get 120 divided by 3 times 3.14. Now I'm just going to do the rest of the calculation over here. So 120 divided by 3 is 40, then times by 3.14. Now, to make life easy, if we multiply this by 10, because 40 comprises of 4 times 10, so we times this by 10, it's really going to be a case of 4 times 31.4. So if we do 4 times 31.4, we end up with 125.6 centimeters. So if we have a look at number 5, it's asking us, as a statistics question, and it's talking about the midday temperatures which were recorded over a 9-day period, and it's asking us to find the median and the semi-interquartile range for these temperatures. So first things first, we need to put these numbers in sequential order. So it's going to be 3, 3, 4, 4, then a 5, 6, 7, 9, and 10. So in order to find the median, all we have to do is work our way from the left and the right into each other until we find the number in the middle. So if we deal with that first, then that number, and so forth until we get to here. So the median is 5. So we'll say the median equals 5. Now, for the semi-interquartile range, they lie to the left and the right of the median, and it's the same thing. So we have to go and find the value that is directly in the middle of these 4 numbers. So you go in once, twice on that side, once, and twice on that side. So the the first quartile, Q1, is going to be in the middle of 3 and 4, which is going to be 3.5. And the same thing for this set. So we've went in 2, we've went in 2. So this is Q2, which is going to be in between 7 and 9, which is 8. Now, the semi-interquartile range, or SIQR, is the average of the two. So we're going to take the 3.5 plus 8 and then divide by 2. Because what we have to do here is take the average of the upper and lower quartiles. So if we work that one out, we get a value of 2.25 degrees. Now, for part B, it gives us another place called NDOC where they also recorded temperatures. However, this time the median was 8 degrees and the semi-interquartile range was 1.5. We need to make two valid comparisons. So we will use NDOC as our comparison, what we're going to talk about. So NDOC, if it has a greater median, then that tells us that we have larger numbers. So NDOC has greater / higher temperatures than the Granford. Now, if we compare the semi-interquartile range, NDOC, because the range is smaller, that means that the temperatures, NDOC's temperatures, are more constant. So rather than having a wide range of values, so 2, 3, 5, all the way up to 15, NDOC might have values that are pretty close together. So there might be quite a few 8s, quite a few 10s, 2s, whatever else. It just simply means that the smaller the semi-interquartile range, the closer and more constant the numbers are. So if we have a look at question 6, question 6 is the equation of a straight line, and it's given us a scatter graph with the line of best fit drawn through it. It's asking us to find the equation of the line in its simplest form. So in order to do this, we need 2 points. And luckily, we have point number 1 here, which is 1.5 and 14, and point number 2 here, which is 3.5 and 8. So if I write these coordinates, we had 1.5 and 14, and then we had 3.5 and 8. Now, before I start, I'm going to label these. So I'm going to call these x1, y1, and I'll call these x2, y2, to make life easier for when we come to find the gradient. Because the formula for the gradient is y2 minus y1 over x2 minus x1. So now we just need to plug in the numbers. So it's going to be 14 minus 8 divided by 1.5 minus 3.5. So we get 6 divided by minus 2, which gives us a gradient of negative 3. Now, the equation of a straight line is y minus b equals m x minus a. So if we substitute in, we will take this point here, okay? So we'll substitute in the 1.5 and the 14. So we get y minus 14 equals, and we have the gradient is minus 3, x minus 1.5. So we have y minus 14 equals, and we break this bracket, minus 3x, and minus 3 times minus 1.5 is plus 4.5. Now, from here, all we have to do is bring the negative 14 across, which will go over as positive. So we get minus 3x plus 18.5. Now, if we left our answer as it is, we would get 2 out of 3, because the question specifically asks for it in terms of f and e. So f replaces the y and e replaces the x. So your final answer is f equals minus 3e plus 18.5. And then for part B, it says use your equation from part A to estimate how many kilometres per litre he should expect to get. So the equation from part A was minus 3e plus 18.5. Now it's telling us that the size of the engine is 1.1, so we're going to do minus 3 times 1.1 plus 18.5. So we get minus 3.3 plus 18.5. So your final answer will become 15.2 kilometres per litre. That's it for questions 4 to 6. Thanks for watching. Don't forget to like and subscribe. And for the remaining questions, look out for part 3, and we'll see you in the next video.